In this video, I'll be continuing with the pattern matching project I was using previously. I've finished the last video using a while loop with the find method on my HTML matcher to print two capturing groups in my regular expression for multiple HTML tags in my text block. Before I move on, I want to first introduce you to another matching method that was added in JDK 9. To demonstrate it, I'll reset my HTML matcher because this method picks up where I left off matching. In this case, I left off having matched everything in the while loop, so if I don't reset, there wouldn't be anything left to match. After the reset, I'll invoke the results method. This returns a stream of objects, instances of an interface called matchResult. Like any stream, I can use it for each terminal operation on this with a lambda expression. I'll have one variable which I'll call MR for matchResult. MatchResult has a group method with an index as an argument, so I'll print the results of calling this with index 1 and then the index 2. This will print text from my two capturing groups. Let's confirm it does that. I'll get my headers printed with the header tag level. MatchResult is an interface type which the matcher class itself implements. Matcher also has a private nested class that implements this interface. It's instances of this class that get returned on this stream. Let me show you the matcher and matchResult types on a slide. The matcher class implements matchResult, which you can see has the end, group and start methods I reviewed with you on matcher. Matcher, though, supports the overloaded version of these methods, which allow you to retrieve a capturing group by its name. Note that I am only showing a few of the methods on matcher in this particular diagram. When you call the results method, you'll get a stream of instances, types, that also implement matchResult. This class is declared on matcher as a static nested class. The actual class isn't really important. You should just know you can use the methods shown here, declared on matchResult. Getting back to the code, let's talk about how this method works. It returns a stream of match results, one for each subsequence that matches the pattern. These are streamed in the same order as they're matched. Underneath the covers, this is really calling a series of find methods, somewhat similar to what I showed you in the while loop above this code. This method doesn't reset the matcher at the start, as I mentioned. Instead, I had to call reset because I had already used this matcher previously, exhausting all matches. The pattern class also has a method that can give us a stream, but this is a stream of strings, which is a stream of the matched subsequences. Let's look at this. I'll first set up a text block to demonstrate a mini snapshot of data you might get back from a tab delimited file. To do this, I want to first change a setting in IntelliJ. I'll go into Settings and select Editor, Code Style, and then Java. I'll select the Tabs and Indents tab, and I want to toggle the Use Tab character. Now when I use the Tab key in the editor, it will insert a tab character rather than 4 spaces, which is the default behaviour. I'll call this text block tabbed text. I'll have a header with tabs between each of these header values. I'll just include 2 detail lines, again using tabs, between the values. Next, I'll split my text by each line using the lines method on the string class. Now for each line, I'll use the flat map operation to get another stream, splitting each line using a regular expression pattern for tab. I have to escape that with an extra backslash in a regular expression. I'll print each tab delimited text value. Running this code to see what we get. You can see each header text and value printed on each line. I'm going to go back to that setting and turn it off. Doing that has reverted to using 4 spaces instead of a tab character. I just wanted to simulate reading this from a tab delimited file, which may sometimes be used to deal with quotes or double quotes in delimited values. Okay, so if you find you really like streaming methods, now you've got 2 more in your toolbox. Next, I want to review matcher's replacement methods with you. I'll reset the HTML matcher again. I'll set up a string variable updated snippet. I'll assign it the result of calling replace first on HTML matcher, passing it the string literal first header. I'll print a separator line, then the updated snippet string. For good measure, I'll print the starting and ending index on the HTML matcher after this call. And I'll also print the value of the current capturing group too. Let's review the output from running this code. What I want you to see is that my h1 tag and its text was replaced with first header without the h1 tags. Notice that the start index is 0, So it started at the beginning because I reset this matcher and the end index was 19. This was the index after the code matched on my h1 tag, including its ending tag. I got the text I had in the h1 tag by calling the group method with index 2, which gives me what was in the original h1 header tag, my heading. How can I replace the first header with some other tag, but using the captured heading text, in this case, my heading? First, I'll just make some room by inserting a new line character after the replace first parentheses. Now I'll remove that next line and insert code that will use the EM or emphasis tag in place of the header tag. If I run this code though, we will find a problem. I get an exception, no match found. That's because I'm trying to use the capturing group before any matches were actually done. The replace first method will perform a match, but in this case, I'm trying to access the result before the method is even called. I could invoke find before this replace first call, but if I wanted to replace the next header, I'd have to keep doing this. The replace first method actually resets the matcher every time it's called. There's an overloaded version of this method though that takes a function and calls that function after a match. This is the place to use your capturing group. In this case, I'll use MR for the variable in the lambda expression for a match result, and I'll just change HTML matcher to MR. Because it's a function, it takes one parameter of type match result and needs to return a string. I can use the match result to query the capturing groups. Now if I run this code, we should find it works. You can see I swapped out the h1 tag for em tags instead, using the same header text as I originally had. There's one other way I can do this, and that's by including what's called a back reference in the string I passed to the replace first method. You've seen that groups in a regular expression are implicitly indexed. You can use back references to refer to the text captured by these groups in regular expressions and also in the replacement methods on matcher. In a regular expression, a back reference is identified by a backslash and a number, which is the capturing group index. In a replacement string in Java though, a back reference starts with a $, then a number, again the grouping index. You can also use capturing group names in back references, replacing the index with the named group. I'll start by showing you a back reference in the replace first method. First, I want to reset the HTML matcher again, and I'll print a separator line. I'll print out that this is using a back reference. In this case, I can reference a capturing group by a $, number, where number is the capturing group. Running this to see what happens. I see that this also worked. Now I'll change my regular expression to use a back reference to match the ending tag. I'll do this after the code that is using the named group, because the next pattern won't have a named capturing group, so I'll insert this after the while loop. I'll invoke the usePattern method on my HTML matcher, which lets me change the pattern I'm using. I need to pass that a pattern, which I'll get by calling pattern.compile. The pattern I'll use is the same as before. My first group is the header tag label, but notice the ending tag. Here, instead of repeating the pattern, I'm specifying \\1, a back reference to my first group. If I run the code, I'll get the same results as before, so this pattern works like the earlier pattern. Now let's replace all the header tags with EM tags. Similar to replace first, there's the replace all method and two overloaded versions of that. I'll copy the updated snippet string and I'll paste a copy at the end of the main method. I'll change the variable name to replaced HTML and I'll change replace first to replace all. I'll print a separator line and this new variable. If I run this now, you can see that all the header tags are replaced with EM tags. In addition to these methods, there are two more methods that are used together to do more customized replacements if you need them. First, let's examine what the replace all code is doing by control-clicking on that method in IntelliJ. What I want you to see is that this code first creates an instance of string builder. It then sets up a do while loop, and in that loop there's a call to the append replacement method that takes first the string builder variable and then the replacement string. After the loop finishes, the code invokes the append tail method. Next, I'll control-click on the append replacement method. I'll scroll up a little bit to show you the API documentation, which demonstrates some sample code. Notice that it creates a new string builder as a while loop using the find method. In the loop, it invokes the append replacement method, and finally, after the loop completes, it invokes append tail. I'm going to copy that code from the string builder declaration down and paste that at the end of the main method. I'll replace that M variable with my HTML matcher variable in all cases. The toString method is redundant here, so I'll remove it. I want to insert a reset statement before this code. I'll insert that directly above the SB variable. If I run this without any other changes, I'll get dog everywhere I had an H tag. You can imagine that's not exactly what I'd probably do. In this case, I'll replace all H1 headers with a head tag, H2 headers with an EM tag, and all others I'll keep the tag, but add a number. First, I'll set up an index variable. I'll remove the dog literal text and then add a new line. Instead of dog, I'll add a switch statement which will return a variety of changes. I'll test the first group's value, making sure it's lowercase, so this will match on H1, H2, etc. If it's H1, I'll replace H1 tags with the head tag. If it's H2, I'll replace those tags with EM tags. For any other header tags, I'll keep the original header, so H3, H4 and so on. Here I'm using the back reference for that H tag. I want to include a number in the header text, so I'll use my index, incrementing that after I use it, followed by a back reference for my second capturing group. If I run this code, you can see that each header was replaced in a way unique to that header. I included the append tail method here, but because my last line was a matching subsequence, it didn't really do anything. If I had had trailing characters in my HTML snippet text that didn't match my regular expression, this would have been appended to the string builder. You can use the append replacement and append tail methods when you need to refine your replacements in some way, as I showed here. Otherwise, you can use the simpler replace first and replace all methods. I'm going to end this video here. In the next video, I'll be looping back to the first two regular expressions I showed you at the start. We'll pull them apart and test them together, which hopefully will take the mystery out of them for you. So I'll see you in that next video.